All right, calculus. Here are two examples that we didn't have enough time to go over in section 4.1 when we are finding min-max values of a function on a certain interval or just finding critical values. Okay, so next in section 4.3, we put it all together. So I've changed number 4 to just find the critical numbers of this function, which will be challenging enough. So this function can also be written as x to the 1/2 over 1 plus x squared. Definitely need to use the quotient rule. Low, d high, minus high, d low, all over the square of what's below. Now it's important to know that whether we set it equal to 0 or there, that this denominator will never be 0. You get x squared is -1, x is plus or minus I, so this will never be 0. That will never be 0 as well. Remember, a critical number is value of x that makes the derivative 0 or undefined, but we don't have to worry about that undefined parts or something not being in the original domain of f of x, as that denominator will never be 0. Okay, as I distribute, here's what I get. Just doing some algebra. So again, this will never be 0, so I simply set this top equal to 0, and I'm going to factor out a 1/2. I know that's goofy. I'm going to factor out a 1/2, and actually x to the -1/2. That looks weird, so I'm really factoring this out. I'm left with 1 minus 3x squared. Distributed it if you don't agree. Now, that's another way to rewrite it. Folks, if x equals 0, then the derivative, which this is, if x equals 0, then the derivative is undefined. Okay, the derivative is undefined if x equals 0. So that is, in fact, a critical value. If x equals 0 makes the derivative undefined, x equals 0 is a critical number. Second one is found by cover-up method. 0 equals 1 minus 3x squared. 3x squared is 1 divided by 3. That's not right. X squared equals 1/3. Take the square root of both sides. That is plus or minus root 3 over 3 as well. You have 3 critical numbers. 0, because it makes the derivative undefined. And a plus or minus root 3 over 3. It makes the derivative 0. All right. Number 5, we will do, it's as I had written out. Find the absolute min and max values of f on, not fon, the given interval. So f of x is equal to x squared minus 4, all of that cubed on the interval -2 to 3. Classic chain rule, u to the third, it would be 3u squared times the derivative of u with respect to x. I do 3 times 2x to give me 6x. Nice, easy derivative there. All right, again, I want to find when the derivative is 0, so I would definitely not, FOIL then distribute here. Instead, cover-up method, 6x equals 0, so x equals 0. Fits in the interval as well. And then I set x squared minus 4. I don't need to write that twice. I just said x squared minus 4 equal to 0. I get x is plus or minus 2. Both plus and minus 2 fit in that interval. So I have 5 numbers to check. Or actually, I only have 4 because -2 is both a critical number, but it's also where my interval begins. I was going to use -2 no matter what. So f of -2, f of 0, f of 2, f of 3. There you go, the algebra. So the min is at 0, -64, and the max is at 3, 125. That is what we needed to finish out our notes with. We will start with section 4.2 tomorrow. This is Yak Math Videos signing out.